Good morning, children. Today, class for the ninth class. Subject is physical science. Children, we are discussing about the laws of motion. We are discussing now about the first law of motion. So, the first law of motion states that every object tried to possess in rest or in a state of uniform motion unless a external force acts upon the object. Every object try to possess in a state of rest or a uniform motion unless an external force acting upon it. So, the Newton first law of motion also called as law of inertia. Law of inertia. Okay. Newton first law of motion also called as what? Law of inertia. So, in inertia we observe two type of inertia is there. One is static inertia. Another one is dynamic inertia. What? Dynamic inertia. So today we are discussing first static inertia. So what is static inertia means nothing but every object try to possess in a rest position unless an external force acts upon the object. What is static inertia? Every object try to possess in a rest position. Every object try to possess in a rest position unless an external force acts upon the object is called as static inertia. For example, a bus is in a rest position. So, when a person stand in the bus, he also in rest, and when the bus starts suddenly, when the bus starts suddenly, he falls. He falls backward. Okay, because of static inertia of the body. Static inertia of the body. Okay, static inertia means nothing but every object try to possess in the state of rest until an external force acts upon the object. Example, when the bus is rest position and a person is standing, at the time the position of person is rest. When the bus immediately start, at the time the person falls backward because of the static inertia of the body. And suppose you take second example, you take some books and arrange some of the books one by one or one upon another. Arrange the book one upon another and remove the bottom book from the heap of the book. Okay, remove the bottom book from the heap of the book. You observe that the position of bottom book changed, but remaining books are as is, are arranged one upon each other, one upon each other, because of the static inertia of the book, because of the static inertia of the book. Next one is children about the dynamic inertia. Okay, dynamic inertia. So what is dynamic inertia means nothing but every object tries to move in, every object tries to move in same direction until an external force is act upon the object. This is called as dynamic inertia. This is called as what? Dynamic inertia. Okay, every object tries to move in the same direction. Every object tries to move in the same direction until an external force act upon the object and change its direction is called as dynamic inertia. So, children, in our daily life, we are playing football. So, when you kick the football on the surface of the ground, it moves in a particular direction. It moves in a particular direction. So, the direction of the football is not changed. The direction of the football is not changed until any other player comes and kicks the football. Kicks the football. So, here we observe that when the ball tries to move in the same direction until an external force is act upon the object. Okay, this is about that one what dynamic inertia. What? Dynamic inertia. Okay, dynamic inertia means nothing but every object tries to move in the same direction until an external force acts upon the object is called as dynamic inertia. So, you know that children, normally we are playing football. When we kick the football on the surface of the ground, the football moves in a particular direction. The direction of the football is not changed unless any other player comes and kicks the football. Football. Children, you know that when the net force acting upon the any body or object means when any force is not acting upon the object, then we can say that the body is in a equilibrium. What? The body is in a equilibrium. Okay, when any net force is not acting upon the, okay, when the net force acting upon the body is or object is 0, we can say that the body is in a equilibrium state. So that's why Newton first law of motion is also called as law of inertia. That's why Newton first law of motion also called as what? Law of inertia. Okay, when the net force acting upon the body or object is 0, the body is in a equilibrium state. The body is in a equilibrium state. So that's why Newton first law of motion is called as law of inertia. What? Law of inertia. So what is now we are discussing about what is the relationship between the inertia and mass. What is the relationship between the inertia and mass? So in our daily life we observe that the riding of bicycle or car. Children, which is easy for you? Children, which is easy for you to push a bicycle or a car? Children, which is easy for you to push a bicycle or car? You observe that to push a bicycle is easy for you and you feel or it is a difficult process to push a car. Why? Because nothing but the mass of the bicycle is less and the mass of the car is more. So normally the inertia of the body or object depends upon the mass of the object. Okay, the inertia of the object is depends upon the mass of the object. So normally the mass of the object is considered as the measure of inertia. Measure of inertia. So when the mass is very less, the inertia also less, and when the mass is more, the inertia also more. So in the above example we observe that one the inertia of bicycle is very less when compared to that one inertia of the car. So the car has more mass, so that's why it has more inertia. The mass of the car is very more, so its inertia is more. The bicycle mass is very less, so its inertia is less, and mass of the object is considered as the measure of inertia. Mass of the object is considered as the measure of inertia. So normally we measure the mass or weight in the kgs. So that's why the inertia also measured in the kgs. In the kgs. So here we are discussing one of the activity. Take two rectangular wooden block, means nothing but rendu karra dimmelu, means nothing but wooden boxes, you know children. Okay, and give the same amount of push at the same time on the both of the blocks, means nothing but at a time only you have to apply some force upon the wooden block with the help of wooden scale. So you observe that when the two wooden blocks have same size, they can move same distances. They can move at same distances. So now in the second case, take the two rectangular wooden blocks. In the second case, take two rectangular wooden blocks, and one wooden block is a higher mass, and another wooden block has lesser mass. Means nothing but you have to take one larger sized wooden block and take the smaller sized wooden block, and same now apply same amount of force on the two wooden blocks. Now apply same amount of force upon the two wooden blocks at the same time by using wooden scale. We observe that one the wooden block have lesser mass moves more distance when compared to the wooden block has higher mass. So here the inertia of the objects depends upon the mass of the object. Children, now we are discussing about the Newton second law of motion. Now we are discussing about what? Newton second law of motion. First we can perform some of the activities to know about the Newton second law of motion. First take a ball and place the ball in the veranda and push the ball gently, means quickly here. Okay, take a ball and place the ball in a veranda and push the ball gently. You observe that the ball acquires acceleration from rest. So initially, before we are applying the force on the object, the state of that ball is rest. But when you apply some force upon the ball, but when you apply some force on the ball accelerated, means nothing but moves. So nothing but here the force that is applied on the ball, the force that is applied on the ball produces acceleration. The force that is applied on the ball produces acceleration. So we can say that one non-zero force is acting upon the object. What? And you know that one plastic ball is there and one cork ball is there, and the size of the plastic ball is somewhat less and the size of the cork ball is more. At the time, suppose when you hit the plastic ball and cork ball with the same force, so which ball can you hurt more, the plastic ball or cork ball? You can say that one the cork ball. Why? Because nothing but the plastic ball has less weight, lighter in weight, and the cork ball has more in weight. And you know that one a bullet that is fired from the gun causes more damage. You observe that one the bullet is very smaller in size, but when the small bullet is fired from the gun, it causes severe damage. Not only that one, in our daily life we observe that one the heavy truck cause more damage than the bicycle. Okay, suppose one wall is there. When you hit the wall with a bulldozer or heavy truck, at the same you hit the wall with bicycle. So the heavy truck, we observe that one which vehicle cause more damage, either the heavy truck or bicycle. Sure, we can say that one the heavy truck. So why? Because nothing but it has more mass. Not only that one, it is also depends upon the speed of the object. So we can say that one all this concept can be explained by the term momentum. Which one? Momentum, which is normally denoted by the symbol P. Okay, all these situations can be explained by the concept momentum, that are momentum is generally denoted by the P. So the momentum of the object depends upon the two factors. Okay, the momentum of the object depends upon the two factor. One is mass of the object, another one is velocity of the object. Velocity of the object. So momentum of a body, momentum is represented by P. Simply we can say momentum is a product of mass and velocity. Momentum is equal mass into velocity. So P is equal mv. M is equal mass, V is equal velocity. So by using that one momentum, we can explain second law of motion. Thank you, children.